Advancing Environmental Mapping and Forest Health Assessments with Drone Imaging, says Andrew Ball, Runariyanan, Navya Rawal, Ria Poru, or Omar Zab, Siddharth Kamath. There's one more person that should be on there. Keywords are autonomous drones, machine learning, forest health assessment, environmental mapping, and drone learning. Um, Background on current work. So currently the USDA Forest Service monitors forests around the world and country using ground-based manual field surveys. That means they need to have a person on the ground to do field surveys, which is far more expensive than our proposed solution, which would be using drones instead. And currently, like most existing research, about like using drones for field surveys focuses on isolated components, but our research, which focuses a lot more on autonomy, would be able to bridge the gaps by creating a better integrated system. So then further elaborating on our solution, it's to create unmanned aerial vehicle that's capable of capturing high resolution photography. And after the UAV is created, we would fly it over designated areas. It collect the photography, which is then processed on the ground. So um, the UAV has a camera, it takes the photos, and then the photos are processed after it lands. Um, After the data is processed and which areas are determined to be like deforested, after all that's processed, the data is sent to the Bureau of Land Management or the United States Department of Agriculture. That's just our proposal. So our
So our
yeah, you can keep going.
yeah. Oh, I was
You
gonna
want,
talk about the next slide.
yeah,
So
you
our
can be,
materials and methods, the drone or plane we're using is a Voluntex Ranger 2400. And this has a payload capacity of 3 kilograms. So that gives us a lot of space to work around with, to put in our Pi, to put in our battery and things like that. And we also bought a FlySky FS16X to be the transceiver for our drone. And the Raspberry Pi initially served two purposes. It was for the autonomy and for the camera trigger, but right now we're just focusing on the camera trigger part, and we'll come around to the autonomy maybe later. Um, and yeah, that's about it for our materials.
yeah. Um, just if Yeah, that's good. Methods. So, as you said before, we'll be capturing aerial photography to be used as we process data. And we found plenty of nearby areas to fly, such as a Forest and East Mark State Park, Vallejo County Park, Castle Rock State Park. And there's also an open space preserve really close to the lab, which is convenient for just like general flight testing. The drone would preferably fly under 400 feet. And if we do end up flying out of line of sight, we'd apply for FAA Part 107 waiver. But for us to be able to collect data, it's not required to fly out of line of sight. Furthermore, the Raspberry Pi high quality camera will capture photos from the air, which would then be fed into machine learning software on the ground. So the photos are stored on the Pi and then uploaded to computer later on, which processes the image and then assesses the forest health. Um, and the machine learning software, it's not, so as we say before, like the machine learning is not going to be on the drone. It's going to be on the ground because if we tried to program it on the drone, it'd be like a lot more restrictive just to like have machine learning like specifically on the drone, and it'd limit our processing power because it has to fly with the drone. So this is just an example of
Yeah, so this is an image of like a forest and how that forest looks using the NDVI index. So as you could see, the less vegetated parts are more towards the middle or the cooler sides, and the denser parts are more to the warmer colors.
yeah. Um,
And then, so what we hope to achieve with this is to make a more cost-effective and quick solution forestry and forest health management than what the current government organizations use because they usually use manual methods of surveying. So this would be faster and allow for more data in many more different areas. And if we succeed, we want to continue this to do some larger scale forest assessment, and also maybe expand to crop assessment and things like search and rescue. And currently, we have our plane purchased, and we also have the Raspberry Pi, which is connected up to our camera. And this has been mounted in our plane. And we've done test flights in different parks. So we're hoping to collect data soon over actual forests. And then we've also built a neural network to classify the NDVI images.
Okay, these are like the old group members, but still we like to acknowledge Dr. McMahon for guiding us and showing us how to research, and Dr. Downing for procuring materials and providing insightful advice for us to continue our research.